Okay guys, in this video we're going to talk about states of matter and dive a little bit deeper than some of the basic stuff you probably have learned in previous classes. So there are lots of different states of matter out there. You guys are probably familiar with the three most common, the solid, liquid, and the gas, but there are other things out there like plasmas and Bose-Einstein condensates and some other ones out there that are kind of unique in terms of our states of matter. For now, in this unit, beginning of the year, we're just going to talk about the three most common ones that we're going to be working with in our class, okay? So we have our solid, we have our liquid, and we have our gas, okay? And if you take a look at them microscopically, inside of a solid, they kind of look like a rigid, kind of a square. Liquids look a little bit more disorganized, and you see these little tails here. Gases look like they're kind of flying around everywhere, all right? So if we take a look at our traditional definitions of solids, definite shape, definite volume, lowest energy, vibrate only, okay? So things you probably have heard before is, how do you define a solid? Well, they have a definite shape and volume. Well, that's great, okay, but you learned that in middle school. We want to take it one step further and talk about what is the energy state at which they're at. So solids are always in the lowest possible energy state for that substance, okay? Their particle movement, and this is another one that we often kind of skip over in earlier grades, is how they move. So for solids, their particle movement is a vibration only, okay? They're not sitting still, okay? So these particles here are not sitting still. For them to be sitting still, no movement whatsoever, they would have to be so cold that there would be zero energy, or basically we had to be at something called absolute zero, okay? So there is a vibration still going on. They just don't have enough energy to break free of those intermolecular forces we talked about previously, and allows them to break around and move past each other. Okay, if we move on to liquid, because liquids have more energy, we call it medium energy. Okay, because they have this medium energy, that allows them to flow past each other. Okay, so they actually can flow and move past each other and slide around, which means that they still have a definite volume. But now they need to take the shape of their containers. They don't fill their containers because they still have a definite volume. They just take on that shape, which allows them to kind of slide past each other and move. Looking at that from a perspective of intermolecular forces, that means that they have enough energy to break and kind of rearrange those intermolecular forces between the individual molecules, but not enough to completely separate from them. Okay. Now we're not talking about breaking chemical bonds here. We're talking about those physical or those intermolecular forces that they can kind of slide past each other. Once you get to that gas phase, okay, at this point the gases have so much energy that they actually are free to move anywhere inside their containers. Okay, so they're free to move and bounce around, and what we say is that they're completely free of the intermolecular forces. The energy that they have is greater than the attractive force of those intermolecular forces. So those intermolecular forces can't hold them anymore, which means they go anywhere they want. Okay, they bounce around, they fly, they go anywhere they want to, as long as they stay inside their container that's closed off. So as a result, they fill the volume and the shape of their container. Okay, what's different here is liquids only fill the volume; they don't have this shape between the two things. Okay, so things we want to focus on, especially for our learning targets in this unit, is about the energy, what energy they have, and this particle movement at the bottom. Okay, the top three things here, here, and here. These are things I expect you to know walking into my room. Okay, but we maybe haven't looked at it in terms of that particle movement yet. Let's take a quick microscopic view of this. Another link site that we take a look at here. So here's your three states of matter. If we click on solids, I like this view because it kind of gives you an idea of what ice would look like. Essentially, it's these hexagonal shapes, but those water molecules, they're vibrating, they're moving. Okay, they're trying to actually break free, but those intermolecular forces are strong enough to hold them all together. Okay, liquids, if we take a look at them, okay, they're moving around, sliding past each other also, but they can't completely separate from each other, so they're still bound by their own volume inside of here. And then when we go to gases, once you boil the liquid off, gases are free to go wherever they want to, okay, until they bounce off a container or wall, because they have so much more energy. Okay, you see how much faster these are moving than the other two examples, okay? So we kind of get a visual of that also here. I'll link this site back to our site too, so you get a chance to review this if you need to do some more information with that, okay? So those are our three states of matter. It's kind of a short video, but we're going to end it here. Thank you.